In this video, I will be talking about the replication in partitions in Kafka topics. Right. So Kafka is basically used for the real-time messaging. And topics are basically a mechanism in Kafka to store messages and maintain them. Right. There are producers who produce message to a Kafka topic, and then there are consumers, Kafka consumers, who consume messages from the Kafka topics. And a topic can have one or more partitions. Theoretically, they look like arrays. Right. So these partitions are basically the log files which are stored in disks. For example, let's say a topic has let's say 3 partitions, then they will look like this theoretically. They have index numbers just like those in arrays, right? But here they are called as offsets. As soon as a producer produces a message to a topic, the message is stored in one of the partitions, right? And the messages are stored in the partitions in an append only order. Right. So let's say for the first time, let's say Kafka broker is basically a Kafka server. It decides to store the message in, let's say, this partition. The next available offset is 0 in this case. Then the first message will go into this offset 0. Then this offset pointer will be increased. Then the broker decides that the next produced message will go into the partition number 1. Then the next available offset will be looked at, and then the message will be stored in that partition. This way the messages are stored in the partition in the append only manner, right? There are ways to decide in which partition the message will specifically be stored. In order to do that, it follows a round robin algorithm to decide in which partition the message will be stored, right? And when the messages are stored in a round robin manner in these partitions, then the ordering of the messages is not known already, right? The messages will be read by consumer in any order, right? Let's say M1 and M2 were produced here, then let's say some M3 comes here, right? Then these messages at the consumer end can be read in any order, like first M3, M1 and then M2, or M1, M2 or M3, like this. So the messages read from the same partition will be read in the given order, in the order in which they were produced, right? But across the partitions, the order of the messages cannot be guaranteed like this. Make sure the messages are read in the order in which they were produced. We basically produce them in the form of a key value pair. When we provide a key along with the message, here value is the message, then the key is hashed and some other operation is performed in order to decide in which particular partition the message will be stored. So whenever you want the ordering of your messages to be preserved, then provide all of them the same key. Let's say you need to produce some messages m1, m2 and m3, and you want to preserve their order in which they were produced to the topic. Then give them same key. Let's say k1, m1 was produced with k1, then m2 you should produce m2 with k1, and then m3 with k1. In this way, the all of these messages will go into the same partition. Let's say the m1 was produced here, m2 was produced here, then the next time when you produce m3, because all of them have the same key, they will be stored in the same partition in the append only manner. So this way m3 will go here, and when the consumer will read the messages, they will be read in the order in which they were produced, like m1, m2 and m3, this way. When we talk about replication in partition, we talk about it because we have when we have a single Kafka broker, then it's a single point of failure, SPOF, right? So let's say the m1, m2, m3 were produced in this in these partitions, right? And the Kafka broker goes down for some time, or let's say it is died, right? Then since the messages are written in the log file, and the log file is basically stored on the disk, then definitely this will be recovered later. But for as long as the Kafka broker is down, this whole service will be unavailable. So to increase the availability of the service, we require at least more than one Kafka brokers, so that the availability of the service can be improved, right? So let's say now we have let's say we are taking 3 Kafka brokers, right? So when we create a topic, during the creation of the topic we provide some parameters, like the partitions and the replication factor. Replication hyphen factor is this 3. So what is happening here, I am telling the Kafka broker to, when I am creating a topic like this, when I am creating a topic, basically a data pipeline, when I am creating this, I am telling the Kafka broker that make 3 partitions in this particular topic. Let's say on in this broker I am creating a single topic, right? Then I am telling Kafka broker to create 3 partitions in this topic. So partition 1 P1, partition 2 P2, and partition this, like let me make it a little bigger, right? So I'm asking Kafka broker to create 3 partitions in this particular topic, right? And the replication factor, this basically tells the Kafka broker that for each partition create its 3 replicas, right? That is, so here the catch is that this number should be less than equal to the number of Kafka brokers, right? As we have 3 brokers as of now, we can give here the number 3, means that for each partition its replica will be created on it's 2 more replicas will be created on the other 2 brokers, that is one here and the other here, right? And for this reason also, this topic will be created on the other 2 more brokers. Okay, now we have 3 replicas of each of the partition, right? Then what happens, one of the partitions, let's say if I choose P1, then one of the P1 on one of the brokers will be chosen as the leader, and the others will be called as the follower partitions, right? And this task is done by the active controller in Kafka broker. In the next part of the video I will talk about what is an active controller, right? So the active controller is responsible for choosing the leader of the partitions. And so let's say this controller, let's say this partition is chosen as the leader, then the others will be treated as the followers. And this and which of the partitions on a particular broker will be chosen as a leader is basically done by using the Raft consensus algorithm.